Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson for Tuesday night, January 24th. All right, guys, we're doing some simple stuff here, and it's actually, hopefully, you're really getting it because it's not that difficult. Remember, we know that if we have to multiply two monomials, like 2x to the fifth, y to the third, times 3x to the sixth y, that we know when bases are the same, we just add exponents. So we'll multiply our coefficients, 2 times 3, and get 6. We have x to the fifth and x to the sixth. So here we have 5 x's. There we have 6. So altogether we have 11 x's being multiplied. We have y to the third and a plain old y. That is not y to the third, that's y to the fourth. Remember, you can do a couple things. One, you can think, oh, I've got y times y times y times y. Or you can stick that little 1 in there to help you get it right. We also know that if we have a power raised to the power, say like this, well, we take each one and raise it to the third power. Okay, the shortcut is to multiply exponents, but you got to be careful here. So 3 to the third is 3 times 3 times 3, which is 27. X to the third, that's a hard one, x to the third, but a lot of you will make a mistake there. Actually say it, x raised to the third power. Oh, it's x to the third. Or put the 1 in there and do a 1 times 3. Y to the third raised to the third power. That's y cubed times y cubed times y cubed. That must be y to the ninth. Z to the second raised to the third, that's z squared times z squared times z squared, which is z to the sixth. There you go. Now, somebody, Matt Bliznick, I believe it was, the other day asked me, what would happen, or could you ever have a negative exponent? Because we were doing a division problem, like say, maybe we'll have 40x to the fifth, y to the eighth, and we're going to divide that by 4x to the sixth, y to the fifth. All right, and Matt knows that he needs to subtract. Well, first he's going to do 40 divided by 4, which is 10. X to the fifth divided by x to the sixth. Well, that's going to be x to the negative first. Y to the eighth divided by y to the fifth. That's going to be y to the third. But one thing you don't realize is why that's negative 1. I know you know to subtract, but it actually makes a whole lot of sense. And in math, we don't like our answers to ever have a negative exponent. So what are you going to do with it? Well, let's take a look at just the x to the fifth part divided by x to the sixth. So let's see here. If I have x to the fifth divided by x to the sixth, well, x to the fifth means all those x's multiplied together, right? And x to the sixth means 6 x's multiplied together. Now, if I take a look at it like I did yesterday, where I kind of do my shade, all right, I know that those two x's are going to cancel out and become 1, right? I know those two x's are going to cancel and become 1. Those two x's can cancel and become 1. Those two x's and those two x's, leaving just a plain old x. But where is that plain old x? He's in the denominator. I need to put a 1 in the numerator, and my answer to this part of the problem is 1 over x. So this negative exponent means I need to use the stairs. The x term is in the numerator. It needs to go downstairs to the denominator. Well, some of you are saying, well, Mr. Lawrence, there is no denominator. But remember, I can write any number over 1. So I'm going to take this 10x to the negative first, y to the third, and I'm going to rewrite it as a fraction. The 10's exponent is positive 1, so he stays in the numerator. The y's exponent is positive, he stays in the numerator. The x to the negative first moves to the denominator, and he becomes positive. The exponent does. Why? Just look back over here. This x right here has a positive 1 for an exponent, doesn't it? Let's try another one like that. Let's try, let's see here. Let's go with, say, 12 x to the second, y to the third, z to the sixth, And we're going to divide that. We're going to divide that by 6, x to the 4th, y, z to the 12th. All right. Well, you might want to rewrite this like this. I love to see it in fraction form. It makes it so much easier for me. And then I'll go ahead and do it. Now, I know my answer is going to be some type of fraction, even if it ends up being a fraction over 1. Well, 12 and 6 simplified to 2 over 1. So I have a 2 in my numerator. I have a 1 in my denominator, but I'm not going to write it unless I need to. Okay? Now, I have x squared over x to the 4th. Well, some of you are thinking, hey, 2 minus 4 is negative 2. So I'll have an x to the negative 2nd. But we don't like to write negative exponents. So I'm going to think about it differently. I'm going to go x squared over x to the 4th. And here I'm going to have x times x. And downstairs I'll have cancel, cancel. I'll have x squared downstairs. So those of you who came up with an x to the negative 2nd, oops, negative 2nd, that has to be the same as 1 over x squared. All right, now, let me see here. Y cubed over y. So I'll have 3 y's upstairs, 1 y downstairs. 1 y will cancel upstairs and downstairs, leaving y times y in the numerator. Well, that means y squared must be upstairs. 6, 12. I'm going to get a z to the negative 6th. But the negative exponent means to use the stairs. If you want to know why it becomes a positive sign, again, z, and I'm getting tired of writing this so many times, so I'm going to use the power of the infinite cloner. 3, 4, 5, 6. That's what my numerator looks like. And then my denominator looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 z's. All right, 12 z's. Okay, and then I'm going to do some canceling. I can cancel 1 z in the numerator with 1 z in the denominator. What's left in the numerator? A 1. What's left in the denominator? Z times z times z times z times z times z. There's 6 z's being multiplied together. So that proves that z to the negative 6th is the same as 1 over z to the 6th. Because look, I have a 1 in my numerator, and I have 6 z's being multiplied together in my denominator. 1, 2, 3, 4, 5, 6. There we go. So I need a z to the 6th in my denominator. Okay. Sorry, it's taking a long time to erase. That must be infinitely cloned. That's why he won't erase. So I can declone him and move him out of my way. Oops. All right. Ah! Here, we'll do this. There we go. Z to the 6th. All right. Now this works for numbers as well. Let's say you're supposed to figure out, evaluate what 5 to the negative 3rd is. Well, I'm going to take a little approach here. 5 to the 3rd, 5 to the 2nd, 5 to the 1st. All right. 5 to the 3rd is 125. 5 to the 2nd is 25, right? 5 to the 1st is 5. What do you suppose 5 to the 0 power is? Now, some of you are shouting out ridiculous answers that don't make any sense. Stop and think. How can I turn 125 into 25? Well, some of you say, subtract 100. But do I subtract 100 to go from 25 to 5? No, I don't. So that's not going to work. So try a different way. How else could I turn 125 into 25? Oh, I could divide by 5. Let's try that here. Is 25 divided by 5? 5? Sure is. So to move down, I'm going to need to divide by 5. 5 divided by 5 turns out to be 1. So 5 to the 0 power is 1. Yeah, you heard me. 5 to the 0 power equals 1. Okay, if you think about it, let's pretend we had 5 to the 6th over 5 to the 6th. Now you know any non-zero number divided by itself is 1. But you could also think about it this way. You're dividing, so you're going to subtract your exponents. 5 to the 6 minus 6. Well, that's the same as 5 to the 0 power, right? And look at that. 1 on the left-hand side, 5 to the 0 on the right-hand side, equal signs all the way through. That means that 1 equals 5 to the 0 power. Okay, so now that I know 5 to the 0 power is 1, now I'm going to go 5 to the negative first. Now before you shout out a negative answer, please just stop and think. Stop and think. Follow your pattern. 5 to the negative first. What did I do moving down the right-hand side every time? I divided by 5, didn't I? Well, I'm going to have to divide by 5 again. 1 divided by 5, some of you are going to say 0.2, 2/10, and you're correct, but don't be a fraction wimp on me. Isn't 1 divided by 5 the same as 1/5? Let's try 5 to the negative second. 5 to the negative second. Oh, okay, I know I have to divide by 5. Well, let's see here. 1/5 divided by 5, copy, times flip, 1/25. Well, hey, look at that. 1/25. 5 to the negative second is 1/25. Now check this out. 5 to the first was 5. 5 to the negative first was 1 over 5. 5 to the second is 25. 5 to the negative second is 1 over 25. Oh, you can't read that, can you? Sorry, let me write those back in there. 1 over 25. There we go. What do you suppose 5 to the negative third is? Well, 5 to the third is 125, right? So 5 to the negative third must be 1 over 125. So once again, I've proven to you that a negative exponent means to use the stairs. A negative exponent means to use the stairs. So 6 to the negative second. Do you know what 6 to the second is? Sure you do. 36. 6 to the negative second is 1 over 36. You flip the fraction. You flip your answer to get the positive exponent. So let's recap real quick, and then we'll cut this video down. What is x to the negative fifth equal? Well, I have a negative exponent, so that means I'm going to use the stairs. Be 1 over x to the fifth. So the x term goes downstairs and the sign on the exponent changes. All right, what is 10 to the negative third? Well, I know that 10 to the third is 1,000. 10 to the negative third must be 1 over 1,000. So how do we use that in a problem? Well, if we have a big problem like this, say 125 x to the 8th y to the 2nd divided by, say, 50 x to the 10th y. I'm going to divide like I normally would. I'm going to simplify this fraction here, which I know 25 will go into them. 25 will go in there 5 times. 25 will go in there twice. So my coefficient in the numerator will be 5, and my coefficient in the denominator will be 2. Now I have x to the 8th divided by x to the 10th, which is the same as x to the 8 minus 10, which is x to the negative second. But the negative exponent tells me to send them downstairs. So this will become an x to the second downstairs. If you don't like that explanation, then feel free to do x to the 8th over x to the 10th. Write them out, cancel them until you're convinced that it'll be an x squared and it'll be in the denominator. Okay, y squared over y, I'll do it this way first. Y squared will equal y times y divided by y. Cancel will be a plain old y. And look, he's in the numerator. And there is your answer. Okay? And then we also learned in the video today that any non-zero number to the 0 power is 1. So that would mean 7 to the 0 power is 1. Right? Whereas 7 to the negative first, well, 7 to the first is 7. So 7 to the negative first, 1 over 7. This works for any non-zero number. If you try to raise 0 to the 0 power, that will be undefined. Okay, so Mr. Lawrence is going to sign off here so that way Quinn doesn't complain that we went over 15 minutes by too much. I think he can give me a 18 to 30 second grace. All right, good night, everybody.